Hi, this is the OCR 21st Century Science P1 revision lesson 8, and in this video we're going to be looking at waves. In the previous video we looked at the idea of seismic waves, P waves and S waves. We're just going to look in a little bit more detail about waves in general, and particularly the wave equation. So waves are typically drawn like this, and the features of the wave that we need to know are the distance from one wave to the next is known as the wavelength, normally written as lambda for short. Now that wavelength is a distance normally measured in meters, and it's the distance from the peak to a peak, or it could be the distance from a trough to a trough, or it could be one point on a wave to an identical point on the next wave. One way to think about waves is if you think of someone sitting on a swing, then the person sitting on the swing would swing forward and back, and then back to the middle again. That's one complete cycle. Maybe a sideways diagram is better. So here's a sideways view of a swing. This point would represent the middle, which is the 0 point. So the 0 point of a wave is in the center. They swing forward, they swing back to the middle again, then back to the outer extreme, and then back to their 0 point. So one complete cycle is from the middle, out, back through the middle, to the back, and then back to the middle again. And that's one complete cycle, or one complete wave. And other aspects of the wave that we can describe it, as well as the wavelength, we can describe the amplitude of the wave, which is here. Now it's important to remember that the amplitude comes from the middle, because the middle is the 0 point. If these waves died down, they would die down to this point in the middle here. If these were ripples on a pond caused by throwing a pebble into the water, then as the ripples die down, they would die down from the top and the bottom and move towards the 0 point there. So the amplitude of the wave. So the amplitude of the wave determines things, for example, like the volume. So if you've got a loud sound wave, then it obviously would have a high amplitude, or if you had a bright light, then that would be a high amplitude. And the final factor to describe a wave is its frequency. And this literally means how often waves are occurring or being made, or how many waves pass per second. So it's defined as waves per second. So if I make, for example, 20 waves per second, then the frequency would be 20 hertz. So hertz is the unit of frequency. Now obviously some waves are much faster than that. So if we had 20,000 waves per second, that would be 20 kilohertz. Or if we had 20 million waves per second, that would be 20 megahertz. So these prefixes often used. K means 1,000. M stands for mega, means a million. So, key facts about waves: the wavelength, the amplitude, and the frequency. Now, these can be combined together to produce an equation which represents how fast the wave is going. Now, if we think carefully about this, if I have a frequency of 20 hertz, i.e. 20 waves made per second, and each wave has a wavelength of 4 meters, then what I'm essentially saying is that every second I make 20 new waves, and each one of those waves is 4 meters long. So every second I'm getting 20 lots of 4 meters. So that wave will get longer each second by 20 times 4 equals 80 meters longer every second. Now obviously 80 meters per second, that's the units of speed. So we can write this wave equation as wave speed equals the frequency of the wave, how many waves per second, times by the wavelength of the wave. Now again, as you know, these are given to you in the exam, so you don't need to remember them. And if you're doing higher paper, then you'll will be often asked to rearrange these equations, and there's a separate video for how to rearrange equations. So wave speed equals the frequency of the wave multiplied by the wavelength of the wave, and we have to make sure that the units are correct. So frequency in hertz, wavelength in meters will give a speed in meters per second, because hertz means per second, so meters times per second gives meters per second.